All right, today we're going to tackle a massive question in the world of finance technology. How on earth do you customize the incredibly complex software that runs an entire bank without, breaking it? I mean, really think about that. Let's say a bank needs to add a brand new validation check for a specific type of transaction, or maybe they need to add a data field that's unique to their country's regulations. How do they do that without risking the entire system that handles billions of dollars? Well, here's a good way to think about it. Imagine a core banking system, something like Temenos T24, is like a massive prefabricated skyscraper. It's incredibly strong, super secure, but you can't just go around knocking down walls wherever you feel like it. Instead, the architects have given you these specific safe outlets on the walls. These are the only places where you're allowed to plug in your own custom appliances. And in our case, those appliances are custom bits of code built using Java. So why even go through all this trouble? I mean, why not just use the software as is? Well, it all comes down to this fundamental tension that every single bank has to deal with.
See, on one hand, you've got the core system. It's built to be standardized because that's what makes it stable and secure. The really critical functions are locked down, and for very good reason. But on the other hand, no two banks are exactly alike. They all have their own unique business rules, their own custom validation logic, and they have to adapt to local laws. The real trick, the real challenge, is figuring out how to do all that custom stuff without messing with the core.
And that's exactly where Java enters the picture. For a long, long time, these customizations were done in a special proprietary language. But switching to Java, that was a complete game changer. Why? Well, for starters, the pool of available Java developers is just massive. This means banks can use their own development teams, which gives them way more control and helps keep costs down. It also opens the door for simpler tools and, this is the big one, much stronger governance and safeguards to protect that core system. Okay, so how does a developer actually do this? What's in their toolkit? Let's pop the hood and take a look at the main components they have to work with. The first and maybe most important tool is something called a hook. Now, if we go back to our building analogy, these are those special outlets on the wall. They are predefined, pre-approved connection points inside the T24 software. You can't just plug in your code anywhere you want. You have to use these specific hooks that T24 provides. And when a certain event happens, like say a user is trying to save a record, T24 automatically calls out and runs whatever custom code you've plugged into that hook. Now, if hooks are the outlets that T24 uses to call your code, then APIs are the official toolkit that your code uses to call T24. Think of them as the set of pre-approved, safe functions that let your custom code read data, check other records, and generally interact with the core system without ever being able to cause any damage. So let's get it straight. Hooks are T24 calling your code, and APIs are your code calling T24. So you have the world of standard Java over here, and the unique data world of T24 over there. How do you get them to talk to each other? You can't just connect them directly. You need special adapters. In this world, those adapters are called T-types. They're basically the bridge. They translate data back and forth. For example, a T-structure object in Java can represent a whole T24 record, and a T-field can represent one single field inside that record. They're the crucial translators that make this whole thing work. All right. That's enough theory. It makes a lot more sense when you see it in action. So let's walk through a really simple, practical example that's going to make this all click. Here's our mission. It's a classic business rule. When a bank employee is entering a funds transfer, we need to add a custom check. We want to make absolutely sure that the currency of the account being debited is the same as the currency of the account being credited. Super simple, but also super important to prevent errors. So how does a developer make this happen? Well, first, they find the right connection port. That's the hook or exit point in the system where this check needs to happen. Then they write the actual Java logic, the code to grab the two currency fields and see if they match. After that, they package that code into a standard file called a jar and put it on the server. And the final step? They just configure T24 and tell it, hey, from now on, whenever you get to this exact point, I want you to run this new piece of Java code. And here's what happens. A user tries to create a transfer from a US dollar account to a euro account. As soon as they try to commit the record, our hook fires. The system runs our custom Java code. Our code sees that USD does not equal UR, and bam, it throws an error right on the screen, stopping the transaction in its tracks. It worked. Now, what happens if the user does it correctly? Let's say they're transferring from one US dollar account to another US dollar account. Well, our custom code runs, it sees that everything matches up, and it lets the transaction go through without a problem. And just like that, the bank's unique business rule is now part of the core system, safely. That's a validation hook in action. So, what's it actually like to be a developer building these things? Let's take a quick peek at their day-to-day workflow. It's a pretty standard modern development cycle. Developers write their Java code in a special program, an IDE. Then they package it up and deploy it to a test server. And then comes the really important part, debugging. They can actually connect their code editor directly to the live running T24 application. They can set breakpoints that literally pause the program and then step through their custom code one line at a time to see exactly what's going on and figure out any bugs. But, and this is a huge but, all of this power comes with a ton of responsibility. The whole point of this framework isn't just to let people add features. As this quote points out, it's designed to protect the core system. A single piece of badly written code, say something that tries to read a massive database table with millions of rows, that could slow down the entire bank for every single user. So governance is absolutely critical. And that really brings us right to our final and most important takeaway. This entire concept of Java extensibility is really just a balancing act between two huge forces. On one side, you have this incredible power. You can automatically fill in fields for users, you can cross-validate information between completely different records, you can even build brand new custom services from scratch. But on the other side, you have the heavy responsibility to govern that power. You have to protect the performance of the core system, make sure data is always accessed securely, and above all else, do nothing that could threaten the stability of the entire bank. So there you have it. That's the secret to how you can safely customize a core banking system. You use a framework that turns a rigid, unchangeable building into a flexible and powerful platform. Which kind of leaves us with one final thought to chew on. If you had this toolkit at your disposal, what's the one custom role that you think would be the most critical for your bank to have?